Okay, here we go, starting in the middle. Sorry, I forgot to press record at the beginning. And I see my writing on my iPad and it's not on the screen because that would just be too easy. There we go. Okay, I at least got that back. Okay, so we're in the middle of finding the molar mass of this gas. So I'm looking at this volume in milliliters, and I need to change that to liters. Hopefully you're getting more comfortable with conversions like that, and you realize that milli means 10 to the minus 3, and so I'm going to be moving the decimal point 3 places. I know that liter is a larger unit than milliliter because I can visualize it. In lab, I can say, oh, well, a milliliter, that's that little tiny part of that little tiny graduated cylinder, and I know a liter is half of a 2-liter bottle of soda. So 213 milliliters must be 0.2 liters, not 213,000 liters, right? That's called using common sense. So 0.213 liters. And then going from Celsius to Kelvin, I'm adding 273.15. So that's going to be 373.15 Kelvin. And then 754 torr, it's 1 atmosphere to 760 torr. Remember, torr and millimeters of mercury are exactly the same thing. So this is going to be close to 1, but it's not exactly. So this is 0.992. There's my 3 significant figures, 11 atmospheres. So I converted volume, temperature, and pressure into the units specified by the ideal gas constant. So now I can use the ideal gas law down here, and I've got pressure 0.99211 atmospheres. And I've got volume 0.213 liters. And I've got the ideal gas constant 0.08206 liter atmospheres per mole Kelvin. I know those units are tedious to write out, but it really is good to do it. 373.15 Kelvin. I'm going to double check my units. Atmospheres cancel atmospheres. Kelvin cancel Kelvin. Liters cancel liters. I've got moles left. This is good. 0.99211 times 0.213 divided by 0.08206 divided by 373.15. So the moles, 0.00, those are not significant figures. 690, there's my 3 sig figs, 12 moles. Any questions? If you got a really big number, you're doing that common mistake with your calculator. So I need to come up here where I'm remembering that molar mass is the mass divided by the number of moles. I already had the mass, so I'm going to put the number of moles in here. I'm using underlined digits to keep track of my significant figures. 0.582 divided by 0.0069012 equals, I did something wrong. I got a syntax error. Yeah, it doesn't like 2 decimal places in one number. 3 sig figs gives me 84.3 grams per mole. Reasonable molar mass? Yeah. Again, if you get less than 2, something's wrong. Any questions?